There's a room in California filled with engineers, screens, and quiet. Millions of miles away, a craft is falling through a thin atmosphere toward a surface no machine from their country has ever touched. Its rockets are firing to slow the descent. But the event they are watching already finished 19 minutes ago. They cannot intervene. They can only wait. Welcome to Same Day, Different Century. I'm Zach. Today is July 20th. The craft falling toward Mars had a name, Viking 1. By the summer of 1976, the United States had already won the contest that defined the space age, the race to the moon, settled 7 years earlier to the day, on July 20th, 1969. Attention had turned outward, to the one nearby world that had haunted human imagination for centuries as a possible home for life. The question was no longer whether America could leave Earth. It was whether it could place a working laboratory on the surface of Mars and have it survive. That had never been done. The Soviet Union had come closest. Its Mars 3 lander reached the surface in December 1971, began transmitting, and then fell silent after about 15 seconds, returning no usable images. A soft landing was not the same as a working mission. Viking was designed to close that gap, and it was the most ambitious and costly planetary venture the United States had yet attempted, around $1 billion in the money of the time. 2 identical spacecraft, each a pairing of orbiter and lander, launched in the late summer of 1975. Viking 1 lifted off in August and spent 10 months in transit, slipping into orbit around Mars on June 19, 1976. From there it began photographing the ground below, because the mission's most dangerous moments still lay ahead, and the team had not yet settled exactly where to attempt it. The plan had been to land on July 4, 1976, the 200th anniversary of American independence. The orbiter's cameras ended that idea. Image of the intended site, a lowland plain called Chrysi Planitia, the Plains of Gold, showed terrain rougher than expected. The engineers refused to commit. They spent weeks combing new orbiter images and old Earth-based radar for somewhere flatter. They eventually found it, still within Chrysi, some 360 miles west of the original target. The landing was pushed back 2 weeks to July 20th. The caution was earned because the descent itself allowed no second attempt. Mars has an atmosphere, but a punishingly thin one. Its surface pressure is less than 1% of Earth's. That was the worst of both worlds. Thick enough to sear a fast-moving craft with heat, yet far too thin for a parachute alone to bring a heavy lander gently down. And Mars was so distant that on that day, radio signals took roughly 19 minutes to arrive. No one on Earth could steer the landing in real time. The spacecraft would have to fly itself through a sequence its designers could only set in motion and then trust. That sequence began high above the Plains of Gold. The lander separated from the orbiter and fired a braking rocket to drop it out of orbit. It fell behind a protective shell, an aeroshell, whose blunt underside took the searing heat as the thin air slowed it. Lower down, a parachute snapped open. But a parachute in that thin atmosphere could only do so much, and it was never meant to finish the job. The aeroshell fell away. 3 rocket engines on the lander's underside ignited, throttling to hold the craft steady as it went the final distance toward the ground. Those engines carried a quiet piece of engineering that reveals what the mission was really for. Each was built not with a single nozzle, but with 18 small ones, spread to fan the exhaust outward. The purpose was restraint. A concentrated rocket blast would have blown a crater in the soil and laced it with the engine's own chemistry. And this lander had come to test that soil for signs of life. Its makers designed the landing so it would disturb as little as possible of the very ground it had traveled hundreds of millions of miles to sample. Viking 1 touched the surface on July 20th, 1976. Within minutes it returned its first image, not a sweeping vista, but a close, careful look at one of its own footpads and the rocky soil around it, built up line by line as the camera scanned. Later frames widened into a panorama of a rust-colored, boulder-strewn plain stretching to a flat horizon. The sky in the corrected images was not blue, but a pale reddish tan, its color stolen by fine dust suspended in the air. Then the mission turned to its central question, the one that had drawn public voices like the astronomer Carl Sagan to the project. Viking 1 carried a compact biology laboratory, 3 separate experiments built to detect the chemistry of living things in Martian soil, along with a 4th instrument to identify the organic molecules that life is made of. A robotic arm scooped up samples and fed them to the machines inside. The results resisted a simple answer, and they still do. One experiment, the labeled release test, added a nutrient broth tagged with radioactive carbon to the soil. If microbes were present and feeding, they would give off tagged gas. The soil promptly released tagged gas, exactly the signature expected from living things. A companion sample, heated first to a sterilizing temperature, produced almost none, which was precisely how a biological result should behave. On its own, the test looked like a detection. But it did not stand on its own. A second experiment, watching for gas exchange, saw the soil give off oxygen far too quickly and in ways that pointed to aggressive chemistry rather than biology. And the molecular instrument, the most decisive of all, searched the soil for organic compounds, the carbon-based building blocks that underlie all known life, and found essentially nothing. It did register faint traces of 2 chlorinated compounds, chloromethane and dichloromethane, but the team wrote those off as contamination from cleaning solvents carried from Earth. To most of the scientists involved, that settled it. You could not have organisms living and dying in soil that held no detectable trace of organic material. The labeled release signal, they concluded, was most likely the work of a reactive, oxidizing chemistry in the Martian dirt that mimicked the appetite of life without being alive. But not everyone agreed with that conclusion. The scientist who designed the labeled release experiment argued for the rest of his life, until his death in 2021, that his instrument had detected Martian biology and that the case had been closed too soon. Most scientists and historians of the mission treat the outcome as not convincing evidence of life, though not a definitive ruling out since the conflicting instruments have never been fully reconciled. While that debate ran on Earth, the lander kept working. Viking 1 was built for 90 days on the surface. It lasted far longer, sending weather readings, images, and data for more than 6 years until November 1982, when engineers uplinked new software meant to nurse its failing batteries, and the command inadvertently overwrote the data the lander used to aim its antenna at Earth. It could no longer find home. It fell silent for good. Beyond the life question, the Viking landers returned the first sustained weather record from another planet. Daily temperatures, winds, and pressure logged across the Martian seasons. Data that still anchors models of the planet's climate. Its endurance record for a surface mission on Mars would stand until the rover Opportunity finally surpassed it in 2010. The landing site was later named for Thomas Much, the scientist who led its imaging team, after he vanished descending a Himalayan peak, presumed to have fallen to his death. The ambiguity Viking left behind shaped everything that followed. Its null result cast a long, cautious shadow, and for 2 decades the search for life on Mars gave way to a narrower, more answerable goal. Follow the water, and understand the planet's chemistry and past before making fresh claims about biology. Then, in 2008, the Phoenix lander found perchlorate, a reactive salt, in the Martian soil. That discovery quietly reopened Viking's file. Heating soil containing perchlorate, as Viking's molecular instruments did, could destroy some organic molecules during analysis, potentially masking their presence. The famous absence of organics might not have been a true absence at all. It may have been the instrument erasing the very evidence it was sent to find. Viking also set the standard by which we still measure how carefully humanity touches other worlds. Because the mission took the possibility of Martian life very seriously, its landers were baked and sterilized to avoid carrying Earth microbes to Mars, an early and still unmatched standard of planetary protection. No Mars lander since has been sterilized as thoroughly. Viking remains the benchmark that later missions are measured against. And every successful Mars lander since has built on the entry, descent, and landing techniques Viking proved could work, adapting them with new technologies such as airbags or sky cranes for later missions. 50 years on, robots still comb the same planet for the answer Viking could not settle, carrying better tools and the hard lesson of that summer, that on Mars, the line between chemistry and life is far harder to read than anyone in that California control room expected. That same day, different century. I'm Zach. We'll be back tomorrow with another date, another story. Thanks for listening. Hey guys, it's Zach. Real quick before you go, I just wanted to say thank you so much for listening. It really means a lot. If you enjoyed the show, all I ask is that you share it with someone that you think would enjoy it too. That's the best way to help us out. I'll see you tomorrow.